Jane has started screen sharing. It's maybe just taking a wee second for the. Yep, that's it.
Okay, doesn't seem to want to go full screen for me, but interesting. Just kind of flashing here. Let me just try one more time. Oh.
If you maybe go to slide up and do the top of your screen and say slideshow present, that might work.
Ah, is it coming through now?
Give it a wee second. There was a bit of a delay the first time. Yes,
Oh.
I think that's it now. Second.
It's okay now?
Just, yes, that's it now. Brilliant.
Yes, apologies, I'm on the laptop here. I don't have a professional setup like Josh had. And I suppose I'd just like to open by thanking Josh for his very interesting talk, because it highlighted to me how our marketing team can do such a good job but still take 2-hour lunch breaks. So they're clearly using AI without my knowledge. But it was very interesting to see just different ways in which AI can be utilized. So I suppose just I getting things popping up all over the place here. I'm still working off of just the one screen here, so hopefully it's all coming through okay anyway, and we can just ignore all of these annotations here. So in terms of what I'm going to talk about, it's about AI and machine learning and the application of that to precast concrete manufacturing. My name is Gareth Robinson. I'm the Chief Engineer for Hydraulics at FP McCann. I've been with the company now for 7 years and joined the company through a knowledge transfer partnership. And I'll talk briefly on that. So FP McCann are the largest manufacturer of precast concrete in the UK. You can see a range of pictures here in terms of the products that we make. We make a wide range of products, including tunnels and shafts, drainage systems, which are like pipes and cover slabs and manholes and things like that, walling, stadiums, and then in the bottom right, one of our newest systems, which is a prefabricated structure, which involves sandwich panels, so 2 layers of concrete with insulation sandwiched in between, and we can make entire buildings from this in a much quicker time than traditional construction. So we're by no means an SME. We have about 1,600 people employed, with a turnover of 340 million per year. But we still like to have that sort of mentality of getting the most bang for our buck. We're not big fans of spending money when we don't need to. So, whoops, go back a slide. The problem that we had was with our largest selling product, which is precast concrete pipes. So pipes are very, very simple. They're just a conduit to move fluids. So you may think, well, I mean, why do you need AI for that? They've been making concrete pipes for years, hundreds of years by this stage. But we're always looking to improve the quality of our products, improve the efficiency of our manufacturing, reducing waste, and also we're very aware of our carbon footprint as well. With precast concrete, well, concrete in general has this stigma of being very bad for the environment. So we're aware of our footprint in that regard, and we're always looking to use new and novel materials in order to reduce our carbon footprint. But the problem we have with our precast pipes is that we test them for leak tightness, because nobody wants a leaky pipe. So they're tested on an automated test line in the factory. But just because a pipe doesn't leak doesn't necessarily mean that it's fit for purpose. So the leak tightness is not really accounting for the full quality assessment of the product. To do that, we actually, our process is very manual. It requires an operative to basically go out with a tape measure and measure the pipe in order to check that it's the right diameter and it has the right dimensions, and those dimensions fit within tolerance. But also, it's very reliant on user experience. Some of our operatives have been with the company for 20 plus years, and they can just tell by looking whether a product is good or not. So with the sort of skill gap, especially in the construction industry, we don't get a lot of new blood coming into the industry. It's one of the big challenges. That experience is slowly leaving the industry, and it provides an opportunity for us to implement an AI or machine learning technology that can learn from that experience while we still have it, and then also be applied automatically to check our products. So the solution then, we were weighing up two options. One was in-house development. Do we do it ourselves, or do we outsource this? So the two options both have pros and cons. For example, if it's developed in-house, you have full control over the system. You can build it, design it whatever way that you want. It can be quite inexpensive, to create a prototype system, but there's also a much higher risk of failure, because I suppose we're not the experts in machine learning and AI just yet. So we can also tailor what we develop to make sure that we can scale the system. So we have 12 manufacturing facilities across the UK. So we want to make sure that we make a system that is actually feasible to put everywhere. And also interoperability is a key one as well. How do each of these systems talk to each other? How do we connect them together? If we design the system ourselves, we can do that. But also with in-house development, we get internal upskilling. So where we're not the experts in AI and machine learning as of this stage, we hopefully will get a better grasp of it and upskill our R&D team so that it can be applied to a wide range of problems. And that's really the big benefit of AI and machine learning. It really is industry agnostic. It can be applied to everything. The pros then for sort of outsourcing is that you get access to the industry experts. With what we were trying to do, there was no off-the-shelf solution available. So it's quite a tricky problem, specific to our industry. So we would require to get experts in. The experts would be quick at developing a system, but what we found in this case was that they were quite expensive too. We put our constraints or our requirements to the experts and then say, how are you going to do it? And I suppose to make sure that the system will work to what we need, there's a tendency to over-specify the equipment that's required, just to make sure that you hit those requirements. So it can be quite expensive. But we also found, talking to other companies, that they were trying to push us towards adopting their own proprietary environments, which include subscription fees. Now, I mean, this can work well in many cases, but for us, we don't really, as a company, we don't really want to be held to to a certain system and become reliant upon that. So we weren't really looking to engage with companies who were trying to sell us a subscription-based environment to do this work. So we ended up deciding to do it in-house, but with the help of academia, and that was through a knowledge transfer partnership, which I would hope as SMEs you're all aware of. The purpose of a knowledge transfer partnership is to partner up with a an academic institution or a knowledge base partner, like a university that knows the technical aspects of what you're trying to do, and apply that knowledge, transfer that knowledge to the company to be applied for a particular problem. So the KTP project that we engaged in was with Queen's University in Belfast, and particularly the civil engineering department, who have a lot of experience in structural health monitoring and image processing, which includes machine learning for structures. And then FP McCann as the supervisor of the project and the application of the technology to a particular problem. And then the third part of the team is the associate, the KTP associate, who actually is working on the project and leading that project. And we ended up hiring an astrophysicist for this project, which is very strange for a precast concrete company. We're mostly civil engineers, other engineers as well, mechanical, some aerospace. But what's an astrophysicist doing looking at precast concrete? Well, as I was saying before, and as Joshua had mentioned as well, there's wide-ranging application for AI. So the KTP associate had a lot of experience using artificial intelligence and machine learning on previous projects to do with astrophysics and nature conservation as well. So the toolkit was there. It was just about the application of that to our problem. The goals of the KTP then were to develop a pipe inspection system, and that system should be equivalent to the checks that we're doing manually at the minute. So I think it's another important aspect of machine learning and AI that needs to be taken into consideration, is that just because you're using it doesn't mean that it's always right. But the expectation shouldn't be that it's always right either. All we need the system to be is better than what we have at the minute. So it can be wrong, and it sometimes is wrong. It's often wrong, in fact, at the start of the project, but over time it'll get better. And again, like I say, all we need it to be is better than what we have at the minute. We can also take it a step further, whereby in developing this system, we will be storing a lot of data, and we want to correlate that data to a depreciation in quality of the product over time, and correlate that with machine wear in order to inform our preventative or predictive maintenance strategies. And we expect that we could get a 20% waste reduction by doing this. So the objectives then were to create an end-to-end data pipeline, which would handle the data from the point that it is taken to the point that it makes the decision and displays that to the users. We also want to ensure that it's feasible, so we can scale it to our 12 facilities. And a very important one for us is that we didn't want to have to pay for any of the software. We wanted to have it entirely agnostic of subscription fees. So here's a picture of a precast concrete pipe. It's very exciting, as you can see. I would point out that this is a bad pipe, specifically chosen a bad quality pipe to highlight the system. And then this is what the system produces. So what you can see is it's basically trying to predict where the pipe is within the image, and then it's developing a three-dimensional point cloud of the pipe in order to calculate the geometries of the pipe, the important geometries, such as the diameter, I suppose, is the most important one, the internal and the outside diameter as well. And then there's a Where the machine learning comes into it is in the areas you can see there highlighted, and there's green, there's yellow and blue. It's trying to predict areas where there are quality issues that need to be looked at. And you can see particularly in the green area there, sort of at what do we say, 8 o'clock on the pipe position, we can see that the end of this pipe is broken at that point. So it's obviously not fit for purpose. It won't form a good joint with the pipe upstream of that. So it's the system is highlighting that there's an issue here that needs to be addressed. Whether that can be addressed in remedial work or whether the product is scrap is another benefit of the AI system, which we haven't yet introduced. But it'll be able to say, yep, this pipe can be fixed, or no, this pipe can't be fixed. So the way this system works is it uses a depth camera. So, or a disparity camera, I suppose, is the actual term. So they operate very similar to how your eyes operate. I mean, if you look at the screen now, and you close your left eye, and then you open that and close your right eye, and you sort of flick between them, you'll see the image on the screen moving, from left to right as you open and close your eye. From that, we can predict depth. So the camera. There's two cameras that are looking at the same product, but there's differences between them, and obviously that distance is big if what you're looking at is close to you, and it's small if it's far away. I feel like I'm going into a Father Ted small far away talk here, but that's how the camera works. So it's predicting depth from the two images. And from that, we can build up the point cloud with the X, Y, and Z data and do our analysis off of that. So the impact of the project, it was developed for 13 months. The project is still ongoing to make it better, refine it, and to look at new products. The KTP is 2 years, so it's 24 months. But within 13 months, we had one system deployed at one factory. But over that 13 months, it was taking images and assessing every pipe that was going through our production, which is over 20,000 pipes. That correlated to or accounted for an additional 95% of pipes assessed, because the manual checks that we would do, it's impossible to do manual checks on every single product that comes through. So we random sample the batch and take our measurements. So with this system, we can look at every one, not just the 5% that are randomly sampled. The measurement error there is less than 1%, which is equivalent to our previous process. And we ended up being able to provide this solution at 1/10 of the cost compared to a solution that would be outsourced, or what we were being quoted by from other companies. And that's because those companies were maybe not willing to take the risk of using cheaper equipment. So the disparity cameras we were talking about before are significantly cheaper than your time of flight sensors, the likes of your LiDAR, laser-based measuring equipment, which could do the same job but are 10 times the price. We also use zero proprietary software, so we're not beholden to any one company or group of companies that can make changes at any point in time without considering our needs. So that was great. But also we were able to upskill over 10 people in the R&D team, as well as the wider production team, sales team, marketing team, in the use of artificial intelligence and machine learning. But I suppose the important thing to consider now is the scalability. which is something that we're still tackling. We're still trying to solve this problem, because we have we could have huge data sets here. So a single computer vision deployment there for at one facility for 2 products is about 25 terabytes of data per year, and this is image data, so it's quite it's quite large, and we're looking at ways to try and reduce that down. But a full computer vision deployment for all of our facilities and all of our products, estimating to be about 640 terabytes of data per year, which is a lot of data. It's expensive to store that data. It's expensive to analyze that data. It's just very, very expensive and difficult to handle such big data sets. And it's important to note that this is only for computer vision systems at the QC stage. What we're also looking at is how can we use AI and machine learning to help us make assessments of the raw materials before they go into the mixer, and then what happens during the mixing. How is the properties of the concrete changing as they become mixed together? There's also pre-pour checks, which we have to consider. We have steel reinforcement, or a wide range of reinforcement types within our products. So how is that steel positioned? Is it in the right place? Is it within tolerance? The likes of our drainage products, we would have chambers that have holes, in the products. Are they in the right position? Are they at the right levels? So we can do a lot with computer vision and in our pre-pour checks as well. And then what is the product like as it demolds? Does it come out of the machine in the right form, or is it does it come out with bits of it partially slumped or falling off? That's good information for us to inform our predictive maintenance as well. And then as the concrete cures as well, so it doesn't just come out of the mold and that's it. It's very much like baking a cake, where the product needs to cure over time, and the properties of it change over time as it cures. It hardens, it becomes stronger, and there's scope there for using artificial intelligence and machine learning to assess that curing process. And we can make significant energy savings there, because we can say that product has reached the strength required in order for us to move it out of the curing bay. So we don't need to have it in a temperature controlled environment for as long. And then also the QC stage that we were talking about. So there's scope for this everywhere, and it becomes a huge challenge in terms of data. What lessons did we learn from the process? Well, we're always in this debate about whether to develop stuff in-house or outsource. We have used both methods extensively in the past, and both have proven valuable. You can see an example at the bottom right there. There's a fully automated mesh frame manufacturing facility. So this makes the reinforcement for the products. That's a turnkey solution. Something like that would take multiple years, maybe even decades, to develop the technology there. So if that's the case, you're better buying an off-the-shelf solution if there's one available. And then in the bottom left there's a video playing. I'm not too sure how good that's coming through over the internet, but it was a system that was developed by one of our R&D team who was upskilled in the process of the KTP, and it's about trying to identify products in the yard. So this one's looking at manhole rings, and you can see that there's little blue squares around where it predicts there will be a manhole ring. And interesting that you can't see, if I move my mouse down here, we have sort of circular shapes as well, and you can see that it's not identifying those as product. So it's only identifying the ones that are actual precast concrete manhole rings, and this was done during a weekend, and the image is taken from a drone, and the training, the labeling, and the training of the data. So just it's another advantage that we're getting, a greater reward from taking on the development in-house. And then I suppose just another few lessons for anybody who's looking to implement AI, an AI solution in their business. Make sure that you can interface with whatever system you're signing up for if you're going into using a proprietary system, because inevitably at some point you'll want this system to talk to another system. So I would recommend certainly trying to get in front of that. Don't become dependent on a system you have to pay for that you then cannot link at a later stage with some of your other systems, because that limits then the amount that you can automate. But also to mention to particularly SMEs, there's significant funding opportunities out there to reduce the risk of trying to develop something in-house. As a large company, I feel we quite often get overlooked by the funding bodies, because they demand that we engage with SMEs in order to avail of higher levels of funding. So I think as an SME out there are funds specifically set up for you, but also there's a lot of large companies like us who are looking to partner with SMEs too, and obviously both companies will get the benefit of whatever system is created in the project, but also you'll get significant funding from that too. So certainly it's something that we're open to if you're an SME, in this sort of space, and the construction industry or the precast industry. We're open to partnering to try and get some of these research grants. That's my presentation. I'll pass it back to you, Gillian, and then we can do some questions and answers maybe.
Brilliant, thank you. Oh, that was great. It's just so interesting to see how, like, such a traditional industry, a company that's been around for so long is really harnessing the power of these sort of technologies, and really, who would have thought FP McCann would be, employing an astrophysicist, even 10 years ago, or maybe I'm wrong, but you know what I mean. It's sort of that sort of misconception about with companies, and I think that's a really good draw for companies. I know virtually everyone is struggling to recruit quality staff of any level, at the minute. And if you're a company saying, look, if you come and work with us, you might be starting off doing, this, but we're embracing these sort of technologies, and you will be helping us with that, and that will be part of your, skill set you're developing. I think that's across a lot of industries. That's a really strong message. We were talking about that at our cobotics and robotics webinar last week as well. Has anyone any questions for Gareth? You can put them in the chat or shout out.
Yeah, I do. It's Nicole speaking. A curiosity, I suppose, getting the better of me. Do you intend on selling the prototype that you have, come up with, measuring your pipes and stuff like that, or is that, you're a commercial secret to FP McCann that you don't particularly want competitors to be getting?
I suppose, Nicole, I'm just a lowly engineer, and that's a question for the commercial team. If it was up to me, I would be keen on providing it to anybody that would want it. In terms of price, no idea. But at the minute, it's just for us, and for our company. There's great scope for it to be used as a tool for helping address the carbon problem with concrete, because we're trying to use all of these different materials, new materials, low carbon materials, and how do they affect the quality of the product, and being able to assess that quality of every single product as it comes through, to be able to say, well, actually, in our lab tests, we didn't see this happening when we used this low carbon material. It could be, it could be very, very beneficial. At the minute, we're telling everybody about the system. We're not giving away the keys to the kingdom, but certainly, if anybody approaches us with a desire to, to have the system, I would certainly be open to talking with them.
Brilliant, thank you.
Thank you.
Mary is asking, can you talk more about your use of open source software? Did you not find the products available lacking in some of the specialities you may have needed for your project that is found in proprietary software?
Yes, I suppose that's true. One of the things that we do here in our R&D team is we basically demand that everybody learns programming. Whether that's engineers who are coming in, or astrophysicists, or even our apprentices coming in, sort of 16, 17 years old with no mathematics background. We teach them programming, and we expect them to engage in the learning of programming, because a little bit of knowledge there can do quite powerful things. So where our open source software is a bit lacking, we can then make up that deficit with our own development. And I suppose as well, where the open source software is lacking, in my experience, I have found that it's mostly lacking in accessibility. So you don't get nice interfaces. I suppose that what Josh was showing earlier, there was a very nice interface to engage with this AI software, and that's not something that you would normally get in open source. It would be sort of your raw, almost at code level interfacing with it. But I find a little bit of knowledge in programming can go a very, very long way in order to solving your problems. In terms of open source software, I mean, the database software is open source. I think it's is it Postgres, SQL? The image analysis stuff, a lot of it is done in OpenCV as well. The artificial intelligence or the machine learning side is handled by PyTorch. Apologies if you can hear a loud noise in the background. It's the the problem with working at both a precast concrete factory and a quarry, is that we can get loud noises. Is it coming through, Gillian?
Not really, no.
Not really.
I
Okay.
Just small background noise, but it's not at all.
No, yeah, because it's deafening me here. But hopefully they'll finish soon. Yeah, PyTorch as well, which is developed by Facebook but released, for anybody to use. It's you get the access of these really, really powerful tools that that you can bend to your own will, and suit your own problem. So yeah, I would recommend. There's lots of courses out there. There's lots of free tutorials. I mean, I'm not much of a reader of documentation. I like YouTube videos of people going through examples, and I think that there's a lot of material out there on how to use these systems. It just takes time and effort, but certainly we think it's worthwhile.
Great. And I know that Martin, who's our lead mentor, and Phil, who's involved in the program as well, are both big proponents of open source. In fact, that's really underlying a lot of what we're doing. Is we don't want to be telling people to buy some proprietary system when open source is really important for